Hi, my name is Arnav and I'm part of Team 289. We are working on the resume profiler solution for the Wells Fargo Global Hackathon 2024. In our team, we have Arun, Hansha, and myself. So we worked on the user story, which is implemented by our solution, and it says, as a recruiter, I want to get resume recommendations based on the keyword search. And moving on to our solution. So the approach of our solution leverages the Azure text embedding models to vectorize the documents and Azure Search to store those vectorized representation of the documents into indexes. Azure Search uses cosine similarity algorithm to return the relevant information in the given context. So why we chose cosine similarity algorithm? Cosine similarity algorithm determines the similarity between two vectors in a multi-dimensional space. It measures the cosine of the angle between the two vectors and is often used in the information retrieval and document similarity analysis, and also in the recommendation systems. Cosine similarity having an edge because it is unaffected by the magnitude of the vectors and only considers the direction, making it particularly useful in the scenarios where the length of the vector may vary, and it is widely used in the recommendation systems. So here in our solution, we have two parts of it. One is the data ingestion part, another is the resume profiler part, which is nothing but the API that we are exposing. So in the data ingestion part application, you need to run it only one time if your um, documents are not changing, or the training data is not changing. But if you have new data coming in, you can run it once again just to add those content into the index. So what we do here, we take the PDFs, the dump of the PDFs. It can be from any source. It could be from Azure Blobs or Google Docs or any other places, or it could be in your local, um, where you keep all the documents in a place and then read them through our application one at a time, and then it extract those texts out of those documents and converts into chunks, and then those chunks are converted with the help of Azure OpenAI embedding models, what you see here, into vectors, and those vectors are stored using the Azure Search Index inside the Azure Search Index in Azure, and that's what about it for the ingestion part. Now for the searching part, so we are thinking of the recruiter logs into Workday, and then it clicks a button or something on the Workday application, and that invokes our exposed API, and that takes the request, which consists of the contexts, like okay, in the natural language, like okay, I want resume which are having candidates having Java experience of 5 years or more, and also have certain things. So like that way you can provide the context. You can also provide how many documents you want, and also say, okay, what is the relevance or the similarity score or the threshold that you're looking for. And you pass all this information into our system. It goes, again converts them into embedding and searches inside the index and takes the results back to the UI, and then we can display it. So this is the sample request and response. We can take a look. So here, as I mentioned, there is a context, there's a category, and the threshold that you're passing in, and the number of matches you're expecting, and the system provides you. results. One thing that we can also talk about, so this is our solution based on um, the Azure OpenAI embedding model and also Azure Search Index. There could be other solutions where you are using OpenAI, which utilizes the ChatGPT 3.5 or 4 turbo models. And also, you can completely build a solution using your own machine learning model. That could be a solution where you are extracting the text from each of them, vectorizing it, and after that you are running your model in order to classify the document into different clusters. And when you are searching, you're looking for, okay, this is my um, search context and what are the different cluster that it is closer to, and from there you can search those documents out with the maximum similarity. So that you could have done. So what we felt that would be time consuming and not so much related, because as I explained earlier, the cosine similarity algorithm, it does the work for you, and which is out of the box coming from the Azure Search Index. So that is the reason we chose this solution. There are other solutions that you have chosen for, but this is the most sleek and yet solving the problem very nicely. With that, I want to rest my case here, and thank you so much.